I want to welcome all of you. Thanks for coming out and sharing what will be probably about 45 minutes of your day with us. Today, we want to talk about AI for system programmers. This is a uh, reintroduction from our perspective of a tool that we've had available for some time that has been on the desks and on the screens of many system programmers around the world that we refer to as Image FOCUS. And its companion, IPLCheck, which has recently been rebranded as IPLCheck AI. So what we're up to today is essentially a description of the elements that are part of the ZOS AI assistant that we have available that you can use for a number of different reasons. I want to emphasize here that this assistant has been around for a number of years, always available to support not only current operations, but your desire to move from one release of the operating system to another. It's only recently that the AI community has essentially recognized these rule-based AIs as part of the machine learning universe and branded them as old-fashioned AIs or OFAI. So you may hear of it in that context, and it is in part the reason why we decided to take this opportunity while there's such a furor of AI to reintroduce it as AI for system programmers. We're going to explain the architecture and essentially how it works. And then we're going to present some real world use cases, one upgrading to ZOS 3.2, and then another one using IPLCheck AI in conjunction with the IBM Health Checker or ZOS. We're going to show methods that can be used for exploring the data that's produced by these tools that allows you to drill down into the logs and findings using three different, quite different interfaces. One SDSF under ISPF and ISPF 3.4, and a new tool called ICECheck, and then ICEDirect, our web-based platform that gives you incredible visual access to the logs and their findings. And then we're going to drop into a demonstration of IPLCheck and show these various options and how they can be used. So first of all, an explanation of the inspection platform. Essentially, this diagram summarizes for you a picture of the steps that are necessary for us to go through the training process of the model itself. Essentially, our team, system programmers, now commonly referred to as data scientists, use their own experience, the experience of customers, IBM formal documentation, and any new PTFs as they come out, essentially to train, retrain, and fine-tune the model in order to provide it not only with a rule set that encompasses what to do with its findings from the system itself, but also a number of pre-programmed prompts that are focused into the system, the specific system that you define, either a running system or some future system, and retrieve those findings from the system and then apply the rules themselves. Looking at the models themselves, this would probably be on the order of about 3 million data points that are possible to be involved in the modeling process itself. Essentially, this process goes on and on and on, not only from release to release, but quite frequently from patch to patch as the scientists find new documentation, get additional experience on their own or from customers themselves. The span of the model, excuse me, includes the normal parm-lab concatenation, JES, VTAM, TCP/IP, CICS, and many other components that can be added on as subsystem inspectors or supplemental inspectors. The process itself begins, as most models begin, with an initial prompt. If you want to get something out of ChatGPT, you have to prompt it. If you want to get something out of this model, you'll have to prompt it as well. It is possible that that initial prompt can be automatically determined by the system itself. That is, it can interrogate its running system to determine the unit address and load parm that were used to initialize it, and then automatically prompt the system in order to kick off the process itself. That's the way we do it when we're working with the IBM Health Checker for ZOS. But if we're doing our work interactively, for example, exploring what needs to be done with a new release, we provide the unit address and load parm of an existing system or a yet-to-be IPL system, and some analytic scope, that is, what do we really want the model to respond to, and begin the process. Once the process begins, the pre-programmed prompts begin to access the system, asking it for additional information. And as the information comes in, the rules are applied against it, and then subsequently additional prompts are asked of the system, and then new rules are applied. The findings are presented in the form of a trace or a log that defines for the user severity levels of concern. It could either be errors, warnings, notices, or informational messages. These findings are entirely deterministic. That is, that it's fact-based, transparent, so that if questions exist about the findings, you can go directly to the log to see exactly what the model did in order to create such a prediction. You can adjust the weights and the measures and the biases on your own if you choose to do that through a set of filtering rules that allow you to change the severity of the messages to fit your particular organization's desire for notification of potential issues that may or may not be false positives in your organization. All of that information is included in the log, and these logs, as you'll see when we get into the demonstration, can be quite lengthy. They can number from 15 to 17,000 records long in a single system. And of course, when you're dealing with more complex inspection prompts that include subsystems and supplemental inspectors, they can range to 20 to 25,000 records in length. So having methods to explore that data is really critical to the tools that we apply so that you're able to make that exploration as quickly as you possibly can. So here's a couple of use cases that I think you'll find interesting. The first one here is our user, our system programmer, sitting at a 3270 terminal, having logged on to the VTAM application that is the interface to the integrity controls environment. His task is to begin the process of upgrading from one release of the operating system to the next. Now, in this case, he's attempting to upgrade from a release, could be 2.2, 2.3, 2.4, 3.1, to the recently announced and soon to be available 3.2. So what he's in essence telling the model is, listen, I want you to use the parameters of this system, and I want you to measure them against what the requirements are for 3.2. And the result of that is a report, a log again, of findings that indicates those things that would be important for him to focus on or her to focus on in their transition to 3.2. Of course, It's critically important that the base system that he's asking to be compared against the 3.2 rules inspect clean against its own specific set of rules, and image focus can make that possible for him really easily. Of course, it's possible that he could be at 2.4 and want to go to 3.1, skipping 2.5. And then from 3.1, he might then in turn say, okay, well, I've got that straightened out. Now let me see what I have to do to go to 3.2. So there's lots of flexibility here to be able to map one release against another in order to determine exactly what needs to be done in order to be able to ensure that your attempted excuse me, migration to a new release of the operating system goes as smoothly as it possibly can. Another use case is to use the tool against the IBM Health Checker for ZOS. In this case, what we would be using is IPLCheck AI. This is a really simple installation. You simply install it, put it on a common set of shared DASD, get the various images in your system to point to that installation deck, and then start the health checker. And from that point forward, it will produce a log. And then under the control of the IBM Health Checker for ZOF, it will continue its process of running and executing new logs, overriding the persistent data set that's created for each of the individual systems. Now, if you're in a relatively small environment, examining 2 or 3 logs might not become too difficult. But when you get to log n, 5 logs deep in this particular picture, you're really faced with a big data kind of problem. At that point, you may have as many as 75,000 or 100,000 records that you might have to examine to determine what in fact might be a problem for you in your environment. So there are a couple of tools that we make available, a web platform and a 3270 platform that can be used for that exploration. And we're going to spend the balance of our time actually examining these 3 different alternatives. Excuse me just a minute. Thank you. So in this picture, we see the 3 alternatives. One is simply to use SDSF or ISPF 3.4 to examine the output from the inspectors as it's presented by the health checker, or to simply go to the log itself and examine the log under 3.4. The intermediate step is to use ICECheck, which is a 3270 command line interface, to essentially explore the data through an interface that presents its findings, if you would, in the form of a dashboard with additional prompts that can extract information from the log that might be critical to you, like a list of data sets or volumes or specific keywords, APF data sets, etc. And a similar interface in ICEDirect, our web portal, that extends that analysis significantly in order to provide you with a more graphical look at what the logs contain. So I'm going to go ahead and end this part of the presentation and go directly to a 3270 environment. Sammy, you can see my screen okay?
Yes, I sure can.
Okay, thanks. So I'm just going to go ahead and log on here. I'm already logged on, excuse me. So the first step here is we're going to go to M.5 because we want to have a look at the system here. We're going to check to see what the current state of the health checker is as it relates to our set of checks. So here's all the health checks that exist at the current time. We're going to do a search for NEZ, which is the high-level qualifier of our check name and see if we have any. And there aren't any at this point in time, so we're going back up, go to the system, and actually start IPLCheck. Okay, so IPLCheck is now running on this system, and if we had 5 systems, we'd have to go and start it on all 5 systems, but as I mentioned earlier, they could all share a common installation. Now when we go back, now we can see all the checks as they exist and are currently running. So you can see some of them run a little bit longer than others. This is a very efficient process. This isn't like having to have a basketball court full of NVIDIA chips in order to make this thing run. Typical inspection of the magnitude that you see here on this screen might take 60 seconds in order to complete. And when it is complete, the things that we can see that are critically important are reports about dynamic changes, that is, changes that have taken place since the last IPL. All right. And so here's the report. Now, if you're familiar with the Health Checker, you know that there are a certain set of rules that govern the information that can be presented in it. So one of the rules is that typically they would prefer that the check not create a set of information that would extend, let's say, beyond 200 records in length. So information presented here is typically relatively brief. And so you can see here what this check is now saying is that, yes, there are some dynamic changes that have taken place in the LPA list, not in APF, not in BPX, not in the BPX parms or linked list or the symbols, but in LPA. Now, it doesn't tell you what they are, but it just simply tells you that they've taken place. So we're going to have to go somewhere else actually to get the detail. Now, when we come back, the other check that's here, which is critically important, is the OPSIS inspection. We'll go ahead and select that. And we can see, again, the brief set of information that is provided in the check itself. And essentially, what this is saying is that there are some data sets on my test system that are inadequately protected. And so obviously, it's issuing messages about that. It's letting us know about different other issues that exist, the integrity issue, et cetera, et cetera. So again, it's brief, but it points out that there are issues and we have to go somewhere else to find out what those are. Now, typically, where we would go to see that would be to go to 3.4 and then pick up the log that was produced at the time that IPLCheck ran. So this log is persistent, that is, the name remains the same all the time. So from one execution of the health checker to the next, this log is going to be overwritten. Now, we can go ahead and view it. Excuse me, edit it. Got to browse it. Sorry, it's in use. So we browse it. We get some information right up front about what its discoveries were. It gives us a message to let us know whether or not the control editor is in fact up and running and has made a verifiable backup of all of our system data sets. That's a critical piece of information. Now, technical support can give you some insight as to how it is you might navigate this log with some degree of efficiency. One of the methods that they might suggest might be something like this: find warnings on a line. So that's a bit of text that's in here that can help you to find what you might be looking for. And so you can see some of the messages that are beginning to come out. There's some JES concerns. Obviously, a lot of those. And so you can essentially explore this whole guy by using a technique like that. You could essentially do something like this. Look for notices on a specific line. I don't think there are any. And you can see you get a lot of sort of miscues here on trying to explore this. This is a really big data set. There's no question about it. This particular one is probably about 12,000 lines long, or 12,000 records long in the finding itself. So these are not particularly productive methods for determining what needs to be done. So as I mentioned earlier, we have a tool that can allow you to, from the command line, bring up a dashboard that will explore this data set for you. Now, you can use this tool from any command line. So you could be in SDSF, you could be in the command line that we have here, 3.4, or you could be in the introductory command line when you first get into ISPF. And the way you do it is just simply go TSO, dollar command line interface, comma, CK. So just that command now. What it's doing now is it's examining the log, summarizing it, and making its information available in the form of this dashboard. So reading from the top in the upper section, we can see the last time that the log was actually run. So it was run today at 8:17. So its age is 0. So it's not a day old yet at this point. We can see the information, excuse me, we can see the image focus release level that ran that log, 18J45, the name of the log. And by the way, if you want to see the log, you can just put the cursor under that white text and you're back to where we started under 3.4. You can see a summary of the findings, warnings, notices, informational messages. We can see that there are verifiable backups. If there were not verifiable backups, that is, if the control editor had not made a backup of your system data sets, that backup name would be in red. We can see the date and time of the last IPL and how old that is in the version that was IPL v2r5. We can see the unit address and load parm, IODF, and member that were used to actually perform that IPL. And if we put the cursor under any of the white text, we'll get a report that shows us exactly what was referred to in that particular load member. And then a summary, again, of the information that was discovered concerning dynamic changes. So as we showed in the report itself, or in the health check report itself, there were some changes in the LPA list. If we put the cursor under the 6 and press enter, then we'll find another report that shows us what those 6 changes are essentially all about. So there were 5 deletes, and you can see the names of the modules that were deleted, and there was 1 add. okay? And below that, you can see the related ParmLab members that contain the information that was examined by the inspector at the time it came up with that conclusion. And that conclusion is derived by comparing the content of those members against what is actually in memory and being used by the system at this particular point in time. Another option that is available here is to create a baseline to examine the content of the log and extract from it all the configuration information that's associated with it and baseline it, and then use it for comparison against future future executions of the model itself. And so we want to see what that baseline looks like. It essentially looks like this. So each one of the major components in the log itself, in this case, the component that we refer to as IPL path, is extracted and put in a container. And that container is in turn tokenized so that the token then becomes a sort of inviolate protector of the content of the container itself. And so one of the first steps that's taken in the comparisons that are done to derive its changes is to validate that the tokens still remain in place. Obviously, if the tokenization seemed tampered with, there would be a message that would say, listen, we'll give you a comparison, but we need for you to understand that somebody seems to have messed with the tokens themselves. And this just goes on and on throughout all of the members themselves. You can see that each one of them is in the baseline and tokenized. If we want to see what actually may have changed, we can put the cursor under, in this case, there's one change. And we can see that that one change, in essence, encompasses a delete of something, and then the addition of something else. And then we can scroll down a little bit. And eventually, we'll get to the point where that new record, that is the one that was added, is highlighted in this display of the current content of that member itself. And so what this essentially allows you to do is to focus on those things that are critically important, that need to be addressed, call your attention to them, let you quickly go to them, examine them, and then make a decision as to what you want to do about them. You can additionally prompt the system if you choose to do it. For example, prevailing keywords and their values. You can see here, these are all the IEACIS keywords, and whether or not they actually were assigned a value or whether, or not, they have a default value. And if they have a default value, the default value is shown next to the word default. And so you can see all of these are defaulting to the various values that I'm highlighting. If there's no default, then obviously there's no value. So this is really handy as well to understand what keywords prevailed out of IEACIS, what the default values were that were associated with them, if any, are the assigned values. If I scroll down here a little bit more. For example, those suffix values that were assigned on the PROG keyword will result in PROG members. And here they are. Looks like there's about 10 or 11 of them that are in play. And their content came from an IEACIS member, which was called IEACIS WS. So you can again, trace this directly back to the responses that were provided by the system when it was prompted for this information. Other things here, of course, you can reset the baseline at any time that you want. Resetting is reserved for the admin of this system. There are two other classes of users. There are auditors and just basic users. Auditors and users are not allowed to perform any resetting. The determination of users is defined by the guardrails that are established using a facilities class profile that allows us to assign responsibility to administrators, users, and auditors themselves. And a message down here currently tells us that the guardrails are active, but we could turn them off if we wanted to. So anytime that the administrator chooses to apply the guardrails, he just simply assigns them, turns them on, and then from that point forward, users who attempt to log in to this interface would be checked against that facility class profile to determine whether or not they had authority or permission to use it and which interface they would be allowed to use. If we are an auditor, we wouldn't begin on this panel, but would begin here on this panel, which is a display of the controls that are controlling interval monitoring and the creation of reports that are associated with an interrogation of the log itself. So in this case, the auditor would be able to see this, but would not be able to update the settings. His interface would change accordingly. We can see the last report that was created. So here's what that looks like. I'll show you more detail on that in just a second. Or we could generate a report in real time. There are two specific reports that can be created. You can have one or the other or both of them sent to you via email on the schedule that you see here. You're running either daily, weekly, or monthly, or all three. To these email addresses who are considered to be admins or to a list of email addresses that are associated with sending specifically to them daily, weekly, or monthly updates. If we drill further down here into the monitor target list, we'll see the interface that would be presented to an end user. That is not an auditor, not an administrator, but just simply a user. Now it's analyzing all of the logs that are associated with IPLCheck across all of the systems that are within the system that I am currently logged on. So my system is SAL1. You can see it up at the very top, but there are other systems that are executing here as well. SAL A through SAL 9. And you can see to the right a summary of the findings that are associated with them. When they were last IPL'd, what was the findings associated with their last inspections? What is the age of the inspection? Do they have verifiable backups? Do they have a baseline? What's the age of it? What's the condition of the process for identifying changes? Are there dynamic changes? And what is the release level of the ZOS system that's running each of these individual systems? Now, it's possible that you may need additional detail. You're just a user, you've logged on, this is what you see. You might want to go to your system, or you might want to take a look at some other system that you might happen to be responsible for. If you do that, you'll get, again, the dashboard with all the attendant information. Notice backups is highlighted in red, meaning there's no verifiable backup for this particular system at this time in this log. And there's no baseline. Now, I'm an admin, so I could create a new baseline at this point if I wanted to. But if I was a user, I wouldn't see this create button. I would just simply see a red indicator that there is no baseline for this system itself. So there's lots of functionality here, lots of ways to explore the content of the log itself. And this, of course, is available from 3.4, but if we happen to be in SDSF, we can also do it there. So we ran IPLCheck. We were looking at the log, the results from the health checker. We said, hey, we want to get deeper into that. We want to explore that data in more detail. We just simply go to the command line and type that command string, and up comes our dashboard with all the specific functions, whether I'm an admin, an auditor, or just simply a user. Now, the alternative to this is the use of ICEDirect, which is our web-based platform. Now, when we say our web-based platform, we mean it in the fullest sense possible. This is not Apache or any other web server that may be available. There's no installation of a web server. This simply comes as part of the image focus delivery and is easily installable as an MVS application. So we would type in our username, just like we would if we were logging on to ZOS. User ID, or excuse me, password. And now we see an interface that's completely graphical in nature. Welcome back. Thanks for coming back. Appreciate that. Our function that we're looking for here is shown in what we refer to as the sidebar. There are various different My applications. One of them is My IPL, which is the equivalent of a process for processing the IPLCheck logs. When we select that, we get, in essence, a panel that allows us to further prompt the system for additional information if we decide that we want to do it. We could specifically focus on a given log, SAL1 again, or we could ask it to create a dashboard of frames for us. And in this case, we're asking it to do so and create 11 different dashboard frames at one time. Or we could switch to an alternate set of high-level qualifiers for log names and do equivalence processing. When I click, in this case, Submit Request, it's now going off and looking at the last 11 logs that were defined to it. Now, it's not extracting the logs dynamically as it does when we're in the 3270 environment, but is limiting itself essentially to the logs that we have defined to the system itself. And so you can see now that there are, let me scroll down here. There are 11 different frames here that have been created, and they contain a number of different sets of information within the dashboards that are created for their individual logs. So you can see there's one down here called IPLCheck SAL0 log. It gives us the date of the last IPL, gives us the date of the last log, what system did it use in order to create the log. In this case, it's D49, and this was back in 2023. It lets us know what the results were from that. and then gives us various individual options. So let me scroll back up to the top and get one that's current. This is my system, SAL1. One of the things that I like about this particular presentation is that it presents information in a summarized form that gives us a pathway completely to the IPL path itself. So you can see here all of the members that were inspected in the report or in the log, and then a presentation of them with little icons that indicate whether or not there may be some particular problem or not. And you can see that this one essentially has a few. The things that are highlighted in green are things that came to life after the IPL was fully complete. The things that are highlighted in yellow are those things that are called NIPS. Members were involved in the nucleus initialization process. And then those that are in blue are those that are associated with the directors that came from IEACIS. And you can see all of that and then explore each one of them individually for problems. And you can see here that in this particular PROG member, the significant problem happens to be that the data set apparently is defined, but it does not exist. So that's a true integrity problem, as it is for others that are in comparable space within this environment. You'll notice that there's little ASs here. These are assisted skills. These are connections, if you would, command prompts against, in this case, ChatGPT, that gives you an understanding of what ChatGPT would say about that particular problem. And so you can use this as a starting point. I'm not particularly enamored with the concept. I mean, I'm enamored with the concept, but not necessarily with the output that ChatGPT applies here. But it's generally pretty strong. And certainly for those that have limited knowledge of what these problems might be, this can be extremely helpful. You can hook this up to any of the large language models. All you need to do is license it and add it to your initialization processes. Of course, there are other things that we can do here. We could, for example, list all the members that are in the data set where this PROG member is. So this is like a 3.4 listing. What's good about this is there's an option up here to show the members in this data set sorted by update date. So you can now get an idea of who's been in this data set and what have they been doing. So you can see P. Harl2, this is Pat Harlow, my good buddy, in support, has been in here and updated this command IF member in June of this year. And then we can look at that member and see essentially what its content looked like today. So we just keep drilling down and down and down, exploring the data to try to get a better understanding of what it does. All right, we'll back up here just a bit more. And we'll go to drift analysis, which is similar to the dashboard that we looked at earlier in the 3270 environment. And if there were changes, they would show up here, and then we could drill down directly into them. Let's see if I can find one that has some changes here. Pretty sure I got one down here somewhere. Yeah. So here's a situation where in this particular system against its baseline, it's reporting one change. We'll go take a look. And here they are. And what I find nice about this is a side-by-side comparison of the member, the way it currently exists and the way in which it exists as a baseline. So the baseline's on the left and the current findings on the right. And so what's additional here is the addition of IODF 99 to this particular member. And that makes it really handy, makes it really quick and easy to see what the changes are that are being executed. And of course, we can look at things that might be added. And of course, this member is added. And we can look at some that might be deleted as well. Okay. All right. Well, that's a quick walkthrough here of the system. And back into PowerPoint here. So you can basically, I hope you get the idea that IPLCheck is really easy to set up, really easy to use on all of your systems under the IBM Health Checker for ZOS. It produces lots of information. Some of it in very summarized form can be addressed through SDSF. But for a deeper level of exploration, we provide two tools. One, a command line interface that we call ICEChecks, and a web-based interface that we refer to as ICEDirect. Now, Sammy mentioned this, but I'll just put this up here again. We will be at Share, excuse me. We will be at Share. And if you're there, any questions in the chat.
All right, it does look like we have a few questions that came up. The first one during your demo was, what is the CLI command?
CLI just simply stands for Command Line Interface. And so essentially it is a PARM that is understood by the underlying application to begin the process of searching for the specific prompt, in this case *CK, that it will execute against. There are a number of prompts like that that application can understand. For example, *VB for validated boot interface that we also have available.
Wonderful. Thank you so much. Another question that came in is, does AI introduce any new risks or concerns around mainframe security or compliance?
Well, that's a really good question. Obviously, we're in the nascent stages of what AI will mean for security generally. In some cases, people are concerned that there may be sort of a war or a battle of sorts between the good guys and bad guys attempting to apply it to infiltrate systems, and the good guys attempting to apply it to keep those people out. So I do think there's possibilities that that it can be a threat. My hope is that we'll develop offensive systems that will protect us from those threats and stay ahead of the game as we go forward. But that story is yet to be written at this point in time.
Wonderful. Thank you. One more is a two-part. I'm going to start with the first part of it.
Sure.
It says you mentioned that IPLCheck AI is old-fashioned rule-based AI. How
Right.
does that compare with the large language models like ChatGPT and others that we hear so much about today?
Yeah. Well, both of them, both IPL check AI and the large language models, are components within machine learning. They differ in that the large language models actually learn from data. They are not in any way supervised in their learning process, other than through examination, through testing of the result that they produce from prompts that are given to them. And that's a long-term process. It's highly sophisticated, takes a lot of computing power, but generally don't always result in answers that make sense. Sometimes people say that they hallucinate. Those hallucinations would not, those kinds of models would not be appropriate for a system programming uh, uh, assistant of the kind of IPL check AI. On that side of the machine learning equation, where we have rule-based deterministic systems, we need to be able to apply rules, understand those rules, understand the prompts that go against those particular rules, and make corrections in order to make certain that the answers that we produce are as accurate and full-throated as they possibly can be. So I think that's the major difference between the two. Uh, again, on the large language side, they are trying to generate an answer based on their understanding of the world. On our side, we are generating a finding based on our deterministic use of rules and prompts that we are in total control of.
Wonderful. Thank you. And second part of that question, it says you also mentioned that the inspection platform findings are fact-based. Does
Yeah.
that mean if a question comes up about a finding that it can be traced back to a specific rule or system response or both?
The answer is both. The findings in the log itself uh, are often challenged by customers. No question about it. And they can lead to interesting discussions in which both the customer and our technical support staff learn things about the customer system and how we are applying, excuse me, IPL check AI or image focus to that system in order to determine whether there are problems or not. But they're easily traced, and that is a critically important thing. We can then take that information. The customer may be convinced that we did it right, or we may be convinced that we didn't get it entirely correct, and we'll make adjustments to the model and then move forward with that for the benefit of all of our users.
Wonderful. Thank you so much, Paul. That looks like it is all the questions that we have in our chat box here. I appreciate your time, and to all the attendees, I appreciate you joining us so much. We will be in contact.